Welcome to the lecture 4 of mass transfer gate preparation. Okay, this is in this we will try to see the Fick's law for molecular diffusion. See, as I have told you that the text I am taking is from Gynecopolis, one of the beautiful book. So in this molecular diffusion, what we are going to define or what we are going to understand is molecular diffusion or molecular transport. It is defined, actually it is in the text here, but still, molecular transport can be defined as a transfer or movement of individual molecules through a fluid by means of two things: random and individual movements of the molecules. Random and individual movements of the molecules. See, we can imagine the molecule, some molecule is moving in a straight lines and changing directions by bouncing off, other molecules. See, generally when a molecule is moving, it collides with another molecule and then it bounces, right? It bounces in another direction. So we can imagine molecules are traveling only in straight lines and they change direction after the collisions. So the molecules travel in a random path. That means molecular diffusion is also known as random walk, random walk process. So this is the beauty of the, the diffusion principle, what we see, right? Now, observe the schematic diagram of the molecular diffusion process, which is shown in this figure 6 here. The molecule A, the molecule A is actually traveling like this, and then it is hitting B, again B, again B, and again A. So it is from point 1 to point 2. There is a diffusion, right? So that is actually description. So the random path, so you can see the text here. The random path, the random path that the molecule A might take in diffusing through B, in diffusing through B from the point 1 to point 2 is shown. So this is the diagram. Okay. So if there are, suppose say near point 1, suppose say there are greater number of the A molecules, yeah, near point 1, if there are greater number of the A molecules, then since the molecules diffuse in randomly in both directions, molecules say will diffuse from 1 to 2, then 2 to 1. See, again, see 1 to, so it has to go from, first 1 to 2 and then 2 to 1, like that. The net diffusion of A is from, ultimately what we have to understand is that what is the net diffusion. So net diffusion is from higher concentration to low concentration regions. So that is what is actually the perception. So let us take an example here. You have a beaker and then in that you have water, clear water. You have clear water there, right? You have, let me take it as green. Yeah, you have clear water. Now if I add, copper sulfate, 1 drop of blue liquid dye, you say, blue liquid dye. So if we add 1 drop of blue liquid dye to the cup of this water, the dye molecules will diffuse, will diffuse slowly by the molecular diffusion to all parts of the water. So ultimately it becomes blue. But to increase this particular, what do I say? To increase this particular diffusion process, or rate of mixing, I should say the rate of mixing. What should we do? To increase this rate of mixing of the dye, the liquid can be mechanically agitated. So if I take an agitation, the liquid can be agitated. Once you drop the small drop of the blue dye, once it touches this, and then if it is mechanically agitated, suppose you take any spoon or spatula, then this process is known as convective mass transfer. Okay. So as analogous to the heat transfer, we have conduction and convective heat transfer. Molecular diffusion and convective mass transfer are also in the similar nature. In the next session, we will see the fixed law of diffusion equation.